Hi everyone, this is Joe Sanderson, and today I'll be sharing with you some information about robotic prosthetics, the information technology that is helping making them possible, and how they'll benefit not only individuals' daily lives, but also how they will help make business more efficient. First, let's discuss a brief history of prostheses. Originally, prostheses were made of wood or metal and they didn't have the ability to move. Think of a wooden leg or arm as you can see in the first picture on the left side of the screen. As we move forward in time, not much changed in design or materials for prostheses. They were made of wood or metal or leather, and as you can imagine, that's hard to keep clean, especially when somebody sweats or, gets dirty, and that wasn't very hygienic. So, as we move to the 1940s, specifically World War II, improved shock treatments and antibiotics helped to save more soldiers' lives. But that also resulted in 3,475 upper limb amputees in the US. In 1948, the Bowden body-powered prosthetic was introduced. This allowed the user to open and close the hook at the end of the prosthetic by extending out the arm or spreading the muscles of the back. That allowed the user more functional grasping abilities. And since then, yet again, not much has changed. These prosthetics are actually still being used today. But there have been great advances in information technology and robotics in the last 20 years, and that's led up to today, where robotic prosthetics are enabling people to have much improved function and, in some cases, almost nearly full function of their limbs. I wanted to go over a few of the groups of people who would be using prosthetics so you have a general idea. Of course, there are many more, such as car accidents and things like that, but just to cover a few general areas, we have stroke victims. There are approximately 800,000 stroke victims in the US per year. Only 130,000 of these result in a death. And that sounds like a great statistic, which it is, except for the fact that now these people often don't regain full function of their body. They will need help to walk or to move. That's where a robotic prosthetic could come in handy. There's veterans, of course. The statistics have stayed pretty steady at 14 to 19% limb amputation among combat veterans. A large number of veterans have traumatic brain injury or a spinal cord injury. Combat deaths are declining, and again, that is a good thing, except for the fact that now these brave men and women are going to need some help to get around. They may need a new arm. They may need help with walking, such as an exoskeleton. And that's where these robotic prosthetics can come in. And again, children, there's birth defects, cerebral palsy, other neurological conditions, and with improved pediatric health care, these children are expected to have a longer and longer lifespan, which again is another great statistic, except for the fact that the use of prosthetics and exoskeletons, which I call prosthetics for those who don't need an artificial limb, come in. These are going to help change and improve these people's lives for the better. I had touched on the fact that there have been major advancements in the past 20 years with robotics, information technology, and prosthetics. Here are the five major advancements. The new materials like carbon fiber, titanium, 3D printing, they allow for lighter, more human feeling prosthetics that aren't as bulky, they're easier to clean, they're much more convenient for the user. Microprocessors, they analyze pressure, regulate resistance, and actually allow movement. These are the small computers that are inside these machines. Bluetooth. Lower limb prosthetics can connect to each other with Bluetooth, and that helps to enable an even stride when someone is walking. Myoelectric technology, that's prostheses can be controlled by muscle sensors on the skin. Say, flex your bicep muscle once, and that will make the elbow bend. Flex it twice, and it'll make the hands close. Also, targeted muscle. This is where a surgeon actually goes in, renervates your muscle, moves your muscle to where he wants it to be, moves nerves to different muscles, and then this actually allows you to think, okay, open your hand. And the electricity signals from the nerves will actually do it. So this is what's considered thought control. There are, of course, many, many benefits to these robotic prosthetics. These people are going to have an improved quality of life. I mean, that's fairly simple to see. They're going to be more socially accepted because they will be able to go out and do things that they normally couldn't have done. They're going to be able to stand. They're going to be able to walk. They're going to be able to use a hand. They're going to be able to shake someone's hand. All things that we take for granted. And they were never able to do them previously, and now they can. In addition to that, there's going to be enhanced strength and endurance, which will help in the workplace, and they'll be eligible for jobs that they probably couldn't have gotten before because of missing limbs or the inability to stand or the inability to walk. Now we're going to get into a very exciting area. The advancements in information technology, computer science, surgery, robotics, and prosthetics all have come together to give us mind-controlled prostheses. The man in the picture on the right side of this screen is John Matheny. He was the first person to volunteer for an experimental prostheses study. DARPA and Johns Hopkins University teamed up together to work on finding out if they could make a mind-controlled prosthetic. The way this has worked is they surgically have implanted the prosthetic's attachment into the humerus bone, which is the bone below your shoulder above your elbow. Then a surgeon has relocated the nerves and the muscles in his upper arm. You can have surgical implants into your brain, which will actually allow you to feel touch. You at this point have neural control of the robotic arm. If he wants to open his hands, extend one finger, straighten his elbow, bend his wrist, all he has to do is think about it. And the sensors you can see on his upper arm actually read the electronic pulses from the nerves that come from his brain. Another interesting thing about this is there's actually two-way communication between the brain and the robotic prosthetic. The information technology allows not only the prosthetic to learn what he wants it to do, but it also allows him to learn what the prosthetic can do and how to make it do it. This type of technology advancement has come a long way since the Bowden body-powered prosthetic. Now, not only is he able to open and close his hand, he also can govern how much strength and how much pressure he uses. He can control each finger individually. He has full range of motion, of course, except for the Vulcan V, so if you're a Trekkie, I'm sorry. And it is, like I said, controlled by his thoughts. And if you have the sensors implanted into your brain, you can also have a sense of touch. You can feel pressure, you can feel texture. These are just amazing advances in information technology. Now we're going to move into exoskeletons. Like I said, I call them prosthetics for those who do not require artificial limbs. This area is going to end up being huge in the business world. An older definition from a surgical dictionary that I found is an exoskeleton is a powered suit of armor being developed for military and construction applications which will protect and augment its wearer's strength. Exoskeletons have become so much more than that now if you look at the healthcare industry and how they will be affecting business. The military's actually been researching exoskeletons since the 1960s. Of course, they wanted people to jump higher, run faster, and be stronger. The first exoskeleton experimentally was in 2010 called the XOS. There were a lot of issues with it being bulky and heavy. People couldn't quite move correctly in it. DARPA has spent $75 million on funding exoskeleton research. And in 2010, like I said, the first military prototype was available, and the first medical type actually came out in 2010. Companies such as Rewalk will help people with spinal cord injuries or strokes, anything that doesn't allow someone to have a normal gait pattern, a normal walking style. These not only support the person and help them move or even move for them, they also actually learn how the person walks. The information technology in these devices not only force a person to step a certain way, but as the person tries to step, it learns how the person walks and assists them that way. Also, there are industrial exoskeletons. A lot of these exoskeletons even have sensors and GPS in them. So there's a lot of advancements going on, and we'll cover some of this. Since the military was the first to start exploring exoskeleton use, we're going to start with the use that the military uses them for. They enable the soldiers to carry heavier loads further. They increase the strength of the soldier. They cause the soldier to use less energy for tasks that they would normally perform, and that energy can be used on other tasks later. So let's say you have a very long hike, the person would normally be tired. With the use of the exoskeleton, they would have spent less energy, they would be less tired, and they would be more productive after their hike. The original designs were very bulky and heavy, and with companies like Lockheed Martin helping with the design and the changes to the design, they have helped to decrease injuries, alleviate muscle strain, they're less bulky, and they even have options that will hinder the soldier as he walks, collecting that electricity and using it to power itself. Medical use, like I said earlier, this will help people with spinal cord, brain injuries, neurological diseases. This will help them walk. As you can see on the picture, it supports the person and aids in their walking. As we discussed earlier, this also learns how the person walks and assists them that way. Increased weight bearing to lower extremities is something a lot of people don't think about. That helps keep your muscle mass and your bone mass healthy. And of course, it gives these people personal freedom to walk around and go do things that they normally couldn't have done. Of course, like with most anything, there are plenty of ethical issues to think about. These are very expensive. Should only the rich have them? Data mining and physical tracking, like I said, they have sensors and GPS. Some workers with or without robotic prostheses could be chosen over other workers for specific jobs. Of course, there's always the fear that these could be remotely operated and force someone to walk out into the street or do something that they don't want to do. And of course, just to be a little bit funny, but if you combined robotic prosthetics and exoskeletons with artificial intelligence, you might get something like that's in the picture on the left side of the screen. So what does all this mean for business? Well, the use of industrial exoskeletons is going to be increasing by 229% between last year and 2021. This is going to improve worker speed and efficiency. It's also going to decrease worker fatigue, and it's also going to decrease the requirement for some heavy machinery. I mean, why buy a pallet jack when you could just have 2 or 3 people that are already on the floor pick it up with the robotic exoskeleton assist? This is also going to decrease work-related injuries, repetitive use injuries, insurance and disability costs, and employee burnout. The machines that assist the people physically through robotics and information technology are going to make it easier for people to do their jobs and less stressful on their bodies. With the advent of robotic prosthetics, we're going to have an increased workforce. More people are going to be able to work where they couldn't have before. Somebody couldn't have a job in a factory if they only had one hand. So now if they have 2 hands or they are able to stand longer, they are going to be able to work. And this is a great thing for businesses and for the employees themselves, because now everyone has a chance to be economically prosperous. This also allows qualified candidates that were unable to pass a physical test due to the inability to stand or lift something up over their head, the ability to work. It's also going to allow injured employees who know how to do the job to return to work, whereas previously they wouldn't have been able to. And of course, the ability to hire wounded veterans. And that's something a lot of businesses think is very important, and I agree. Thank you very much for your time, and I hope this helped to open your eyes at the future of work and the future of recovery. Robotic prosthetics and the advances in information technology are truly sweeping, and they are here, and they're going to continue. And I hope you learned a little bit about it today. Thank you very much. Here are some questions I'd like for you to ponder regarding the future of robotic prosthetics. Thank you again for your time and attention.